It's algebra time, and today we have lesson 8-6. We're going to be multiplying polynomials times monomials. Now, it may sound a little bit tough at first, but we're actually going to be using things we've already learned. For one thing, we learned about the rules of exponents earlier in chapter 8. Remember, that's the product rule, the quotient rule, the different power rules, and also the negative exponent rule and the zero exponent rule. Well, today what we're going to be doing is we're going to be using some of the rules of exponents, mainly the product rule, a little bit with the quotient rule, and a little bit with the different power rules. But we're going to use those rules of exponents with the distributive property, something that we've used many times before. And we're going to use these two ideas together to multiply a polynomial times a monomial. So the best way to learn this lesson is to just dive right in and start the examples, because I think you're going to find them pretty easy. So let's take a look at example 1. So you notice that we have the monomial sitting outside the parentheses, the negative 3x. And then we have three terms sitting inside the parentheses, 5x squared, minus 4x, and plus 7. So we all know how the distributive property works. We just have to multiply that negative 3x times each of the terms inside the parentheses. But we have to remember, when we are multiplying like bases together, then we're going to add the exponents of those like bases together. So for example, when I multiply an x times an x squared, that's going to give me an x cubed. When I multiply an x times another x, that's going to give me an x squared. So let's go ahead and distribute the negative 3x times all the terms inside the parentheses and see what we get. Okay, that one was pretty easy. Negative 3x times 5x squared gives us negative 15x cubed. A negative 3x times negative 4x. Negative times negative, remember, is positive, so that gives us a plus 12x squared. And then negative 3x times 7 gives us negative 21x. So our final answer is negative 15x cubed plus 12x squared minus 21x. Now, don't forget, always check what you think is your final answer for any like terms. Because if you have any like terms, you need to combine them. You need to add or subtract like terms together in order to have your true final answer. Okay, that one was a little too easy. Let's try a tougher one. Time to take a look at example 2. Now, this time the monomial sitting out in front of the parentheses is negative 4xy. And inside the parentheses, once again, we have a trinomial. We have three terms sitting inside the parentheses, 5x squared minus 12xy plus 7y squared. Now again, we have to use the distributive property and multiply the monomial, negative 4xy, times each of the terms inside that parentheses. Now why don't you pause this and try to do it yourself, and then come on back when you think you have the right answer, and I'll have the right answer for you. Okay, there it is, the correct answer. Is that what you got? Let's see, we had negative 4xy, and first we multiplied it times 5x squared. That's going to be negative 20x cubed y. Remember, multiply like bases together by adding their exponents. X times x squared, that's how we got the x cubed. Okay, then we multiply the negative 4xy times negative 12xy, and that gives us plus 48x squared y squared. And then finally negative 4xy times 7y squared, and we get negative 28xy cubed. Now check to make sure that you don't have any like terms, and we do not, because in order to be a like term you have to have the same variables, but those variables, the corresponding variables, must have the same exponents. So we can't combine a term that has x cubed y with an x squared y squared with an xy cubed, because the exponents don't match up. So, looks like our final answer is negative 20x cubed y plus 48x squared y squared minus 28xy cubed. Got a couple more examples. They get a little bit trickier, but I'm going to show them to you right now. Well, I decided to give you one that's a little bit tougher here. So let's take a look, because we have two distributive properties going on here. We have the 2x as the monomial sitting outside of the first parentheses, and we have negative 5 as the second monomial sitting outside the second parentheses. Yeah, we definitely want to remember that that's a negative 5 when we distribute it to each of the terms inside the parentheses. And that's one of the most common mistakes that people make, is they forget that negative. So we have two different distributive procedures to go through. First, we have to multiply the 2x times the first parentheses, and then multiply negative 5 times the second parentheses. So let's see what we get. Okay, well, let's see what happens after we distribute the 2x. We have 2x times 4x squared, that's how we got the 8x cubed, and we have 2x times 5, which gives us a positive 10x. Now we distributed the negative 5 times all three terms in the second parentheses, and we got negative 10x cubed. Then we had negative 5 times the negative 3x to give us positive 15x. And finally we had negative 5 times negative 7, which gave us positive 35. Now remember, we have to always check after we do our multiplication to see if we have any like terms, because we're not done until we combine like terms. And as you can see, we do have like terms. We have 8x cubed and negative 10x cubed. They have to be combined together. And we have 10x and 15x. They're like terms. They need to be combined together too. So let's do that, and then we will be done with this problem. There we have our final answer. 8x cubed minus 10x cubed gives us negative 2x cubed. 10x plus 15x gives us a positive 25x. And the 35 is tagging along just for fun. So our final answer, negative 2x cubed plus 25x plus 35. Now we've had three examples and they've all been expressions. How about a polynomial equation to finish off this lesson? Let's do it. All right, this one looks a little bit tougher. It's not just an expression, it's an equation. And you know what that means. We have to solve it. Yep, we have to get the x all by itself on one side of the equation and the numbers on the other side of the equation. But we aren't even close to want to do that yet, because first we have to simplify both sides of the equation. You can see on the left side of the equation, we've got the distributive property going on, don't we? We've got that x as the monomial sitting outside the parentheses. So we're going to have to use the distributive property to multiply that x times the x plus 2. Then on the right side of the equation, we have the distributive property happening again, don't we? We've got the x being multiplied times the parentheses x minus 4. So remember, don't get over anxious trying to get that x by itself right away. We can't even think about doing that until we simplify both sides of the equation. So let's start simplifying. Let's do the distributive property on both the left side and the right side of the equation. As you can see, I distributed the x and multiplied it times the x plus 2 on the left side of the equation. And that gave us x squared plus 2x. Now, the minus 3x, that was sitting outside the parentheses, so we did not distribute the x and multiply it times that negative 3x. It just went along for the ride. Then, on the right side of the equation, you notice that I multiplied the x times the x minus 4 to give us x squared minus 4x. So, now we're ready to get the x by itself, right? Wrong. What do we have to do? Oh yeah, check out the left side of the equation. Have we combined like terms? Not yet. See, on the left side of the equation, we have 2x minus 3x. We have to do that first. So let's combine like terms and see what we have. Well, let's see, we had 2x minus 3x, and that gives us negative x, doesn't it? So the left side simplified to be x squared minus x, and it's equal to x squared minus 4x. Now, I know that looks a little bit strange, but remember what we're trying to do. We're trying to get x all by itself on one side of the equation. So don't freak out just because the problem looks a little bit different. Take a look and analyze it and think, what could we do to make the left side and the right side a little bit easier to work with? Do they have anything in common? Oh yeah, they do. They both have x squareds. So why don't we do this? Why don't we subtract x squared from both sides of the equation, and then that way it'll simplify things. Let's do that right now. Remember that you can do the same operation to both sides of the equation and the equation remains balanced. The left side and the right side remain equal to each other. And that's what we did. We subtracted x squared from both the left side and the right side. And it gave us negative x on the left side and negative 4x on the right side. Now, the one thing that we haven't done yet is we have not yet gotten all the x's on one side of the equation, and we still have to do that. Now, remember, the best way to do it is to cancel out the smaller of the two variables. Well, in this case, it means the one that's more negative. So, I'm going to cancel out the negative 4x on the right side by adding 4x to both sides. Remember, even though the problem looks a little bit different, you still need to follow the rules for solving equations that we learned a long time ago. So, let's get all the x's on one side of the equation by adding 4x. Phew, almost done. Now, again, I did the same thing to both sides of the equation. I added 4x to get all the x's on the left side. Negative x plus 4x gives us 3x. And negative 4x plus 4x, well, they cancel out and give us 0. Now again, that's sometimes a little uncomfortable for people to look at. They go, wait a minute, can it be equal to 0? Sure, why not? 0 is a perfectly good number. Now all I have to do is get the x by itself by dividing both the left side and the right side by 3. So let's do that and finish this puppy off. Well, I divided both sides by 3, and that gives us x equals 0, because 0 divided by 3 still equals 0. And don't forget, we just found the solution to an equation, so put your final answer in solution set form. Well, there you have it, multiplying a polynomial by a monomial. I hope you do a great job on tonight's homework, and we'll see you next time.